Hello, it's algebra on AMC-12. So AMC-12 means the problems are more advanced than we considered so far. We considered AMC-10, AMC-8 partially, but AMC-12 is really more advanced. So you have to demonstrate more knowledge. So the parabola with equation y equals ax squared plus bx plus c and vertex hk is reflected about the line y equals k. This results in the parabola with equation y equals dx squared plus ex plus f, which is the following equals a plus b plus c plus d plus e plus f. Okay, so if you want to solve the problems like that purely based on algebra skills, without any graphs, so you're in a trouble probably. But if you draw a nice diagram, it must help you enormously. So let's assume this is a parabola without loss of generality. So we can assume the parabola looks like this. This is h, this is k, coordinates of the vertex, and we reflected about the line y equals k. Y equals k is the horizontal line. So when I reflect it, it looks like this, right? So this is ax squared plus bx plus c, and this is dx squared plus ex plus f. So now, based on my knowledge of parabolas, I can compare them. So first of all, let's take a look at the y-intercepts. So the y-intercept of the first original parabola is, of course, c, because if you put x equals 0, the value is y is c. So this is c. So in the second parabola, if you put x equals 0, it's f. Y-intercept is f. Y-intercept is f. And due to the symmetry of the two parabolas, k must be an exact midpoint between c and f. What does it mean? So this distance from c to k and this distance from f to k, so they are the same. So it can be written this way: the arithmetic mean of c and f, that is the sum of c and f divided by 2, is equal to the midpoint. It's equal to k. So c plus f is equal to double k. That's the first fact that we have. The second fact, let's continue comparing the two parabolas. So I see their x coordinates of the vertex is the same. X coordinates of this vertex is given by the famous formula minus b divided by 2a. Minus b divided by 2a is the coordinate of the vertex, x coordinate of the vertex for this parabola. It must be equal to the x coordinate of the vertex for the second parabola, reflected parabola. It's minus e divided by 2d. So both values are equal to h. So I can multiply both sides. Oh, no, it's not both sides, but three sides of this equation by -2, right? I multiply by -2. So it means b over a is equal to e over d is equal to minus 2h. So what does it mean? So I take a look at this equation, multiply both sides by a. So b equals minus 2h times a. And then I consider this equation, multiply both sides by d. So e equals minus 2hd, OHD. Okay, so then it's the second fact. The fact number 3, so let's use violet color number 3. So let's see, what can I see? Oh, so for my first parabola, a was a positive number because a is positive because the parabola opens up. But the red parabola, the reflected parabola, has its leading coefficient d less than 0 because it opens down, but due to the symmetry, their absolute values must be the same, right? So it means a plus d, the sum of the two values is equal to 0. The sum of the two values is equal to 0. So there now combine these three facts that came from the comparison of the two parabolas, and then I'm able to find a plus b plus c plus d plus e plus f. So what is C plus F? C plus F, C plus F, it's 2k. Okay. A plus D, it's 0, so they cancel out. Let's take a look at B plus E. Okay, let's see here. Let's look at B plus E. It's minus 2HA minus 2HD. If minus 2H is taken out, what I have inside the brackets is A plus D. It's 0 again. It's 0 again. So B plus E is 0 again. So they cancel out again. So the result is 2K, just 2K. It's E. It's E. Look, it's only the problem number 13. But look at how much skills you have to demonstrate. So let's move to the next problem. Okay, it's problem 7 from 2005, AMC-12B. What is the area enclosed by the graph of 3x by its absolute value plus 4y by its absolute value is equal to 12? Okay, so we consider only the part where x is bigger than 0, y is bigger than 0, or probably equals or bigger than 0. Bigger than 0 or equal to 0. So, because other parts of this graph are symmetrical to the region that we're going to have for x bigger than or equal to 0, y is bigger than or equal to 0. That is in the first quadrant. So if x is bigger than 0, y is bigger than 0, then we can skip or remove this absolute value brackets. It's 3x plus 4y is equal to 12. So let's put it on the xy plane. So in order to be fast with drawing this graph, I used by points method. If x equals 0, then you see y is equal to 3. Let's put it here, y is equal to 3. If y is equal to 0, then x is equal to 4. So this point, yep, it's this point. Then we connect these 2 points with a straight line because apparently it's a linear function, it's a straight line. And then we see what I said, that the other parts of the graph are just symmetries. Symmetries is due to the absolute values. So the other part of the graph looks like this. It comes to -4. This is -3, and this is 4 again. So it's a diamond. Yeah, it's rhombus. So how do we usually find the area of the rhombus? We find the area of this one triangle, and then we multiply it by 4 because the diamond consists of 4 identical copies. So area of this triangle is a half times base 4, height 3, so it is 6. So we have 4 identical triangles. 6 times 4, 24. So the area is 24. So it was substantially easier problem. Then we can move on. Okay, so next problem, 2007, problem 18. It's polynomials. And f of x is the polynomial of 4th degree. It has real coefficients. and we have two roots of the polynomial. It's pure imaginary 2i and complex 2 plus I. So what is a plus b plus c plus d? Okay, so it's a famous theorem that says that if we have a complex root of the polynomial with real coefficients, then its conjugate, the conjugate of the complex root is also the root of this polynomial. So the first root is 2i. The second root is its conjugate. Conjugate of a complex number is the same number, but with opposite imaginary part. So imaginary part of this number is 2i. So opposite conjugate is minus 2i. So the third root of this polynomial is 2 plus I. 2 is real part and I is imaginary part. So the next root is a conjugate of this number. It's 2 minus I. So this is the full set of roots of the polynomial. So having these two roots, we can write down the factors that correspond to this two roots: z minus 2i, z plus 2i. So open the brackets, it's z squared plus 4. So this is a factor, quadratic factor, that corresponds to these two roots. And then we come to this couple of roots: z minus first root, 2 minus I, and z minus 2 plus I. So you can open the brackets or use other methods of finding the factor, the quadratic factor that corresponds to this couple of roots, but it's z squared. Then I can sum up the roots. So the sum of the roots is 4. That's why the coefficient of z is minus 4. So the product of the roots is, what is it? It's 5. The product of the roots is 5. Then the free term of the quadratic factor is also 5. So I'm just using Vieta's theorem, the relationship between the roots of the quadratic equation. So this is the second quadratic factor. So f of x has two big factors: z squared plus 4 and z squared minus 4z plus 5. So I'm sure this factor corresponds to this couple of roots, and this factor corresponds to this couple of roots. So I don't want to open the brackets. Because you can think that opening the brackets is a good idea, because once you have opened the brackets, combined like terms, you can see f of x in this form. The only difference is that I have to use x instead of z, but it doesn't matter. So instead of doing so, I can be a little bit trickier. F of 1, let's consider f of 1. It's, what is it according to this notation? F of 1 is 1 plus a plus b plus c plus d, but it's just one bigger than the value they're asking. So just one bigger than the value of a plus b plus c plus d. So let's find f of 1 when the f of x is, f of z is factorized. So it's 1 plus 4, it's 5. 1 minus 4 plus 5, it's 2, it's 10. Am I right? Let me check. 6 minus 4, 2, 2 times 5, 10. So f of 1 is 10. But f of 1 is 1 plus a plus b plus c plus d. So a plus b plus c plus d is equal to 9. So that's it. 3 wonderful problems. I have to make a note that you have to be familiar with the basic theory of polynomials before you tackle the problems of this scale. So it's 3 problems. from the topic I call algebra and functions, from AMC, algebra and functions. So see you next time in the next video.